What's up, everybody? Thank you for having me. Thank you, Erica. All right, so I'm Matt Wright. I'm a co-founder and CEO of Gaia. We're building decentralized AI inference. I guess what we're talking about today is owning your AI and how you can deploy your own Gaia node. You can run your own AI inference. Quick background on myself before I dive in. Former hackathon and accelerator organizer for various years. So I used to organize hackathons all throughout Asia with a group called Angel Hack, and then did blockchain at JP Morgan on Quorum as a private permission fork of Ethereum, and then worked at Consensus Software for 4 years, building out DevRel and dev communities. And so Consensus, Robert and I work together at Consensus, so old colleagues. But why, like, how did we get into AI, right, from Web3? And I think the biggest thing for me that we'll go through are the massive opportunities to leverage this trustless software for AI agents, AI inference, infrastructure coordination. We'll dive into a lot of that, but Web3 is a very needed piece for AI, even though a lot of the, let's say, traditional AI folks don't believe it yet. So right now what we're seeing in AI and in general internet technologies is a lot of data is being taken from us, especially if you're using ChatGPT, Anthropic, Claude, a lot of the closed source models and applications. We're willingly just giving away our data. We're giving our kind of how we engage with this technology and that data to these companies. And really, at the end of the day, if we looked at a lot of Robert's kind of framing, thank you so much, on internet technologies, we can slowly start to see that we again will become the product. And really, machine learning should be the product and how we coordinate data, not us ourselves as users and developers. And so in the current model, we have a lot of censorship and bias. A lot of these models are developed in silos in Silicon Valley or Guangzhou or Hangzhou. They're not actually trained with the communities in mind that are using them. We have a lot of bias in that as well. And so we have a very small group of people really controlling kind of how this software that we're going to be using on a daily basis, how it is built and served. We have a lot of control and governance issues with AI where, again, we don't get to decide as power users of these systems which models we're using, which tools we're using as developers, how we're serving it, how we're charging for it. At the end of the day, OpenAI is just going to tell you owe them 20 to 30% of any revenue you make, just as you see with Google and Apple stores, digital application stores. Privacy and IP issues. I have a fun slide in a little bit, but there's a ton of concerns around what are they doing with my data? Did I give them permission to utilize this likeness of myself? There's various operational issues. So the composability of the current stack is really closed, at least in big AI. You can use their API endpoints, but beyond that, the composability is really what they give you. You don't get to really create your own stack behind the scenes. In open source, it's a little more open, but it's still there's not a lot of trust in that ecosystem quite yet. Then we have economic constraints. So again, like you aren't able to really build strong businesses on top of a lot of these tools yet. You're kind of at the disposal of the either the kind of open source tool or the centralized company. So like privacy and IP issues, this should give you a visual. You have, OpenAI is just going to become a law firm at some point. Like they're getting sued left and right by every media company you can imagine in the U.S. They just had this, the whole Ghibli thing where you could turn anything to Ghibli. Super cool, but I guarantee you some team there did not have the right to go and do that. It becomes very dangerous when you see at scale, like artists completely losing their likeness to machines and not being able to monetize that themselves. And so, very cool tool, very cool opportunity, but again, like I'm just waiting for the news for Studio Ghibli to press a lawsuit. And then there's also like if you go to like ChatGPT or Claude, like they'll give you this guarantee that they're not training their data on your data, that's also a loss and a missed opportunity. Like I wish my knowledge base would grow with me, but also I don't know if they're actually not using my data. So there's a lot of lack of transparency. And then, yeah, a lot of the economic constraints. A lot of the larger models that are hosted by centralized AI companies are very expensive to run, especially if you're running like a large language model for a very kind of broad scope. If you ask an LLM with a specific trained context, a specific question, you actually are much more efficient. So it's just kind of a visual of like the economics of centralized AI and decentralized AI. There's a lot of operational issues, so a lot of the tooling and the inference, the LLMs, you're not able to kind of own or compose how those tools work in your applications. You have to, again, kind of just see how they, set it up for you. I've tried to deploy a few other projects with, some Web 2 kind of crossovers, and you have to, request to use the API and give the token key, and it's just a lot of, it's not permissionless, and so we're still kind of waiting for that to happen. And if the trade-off is, okay, well, I can just use Llama and build an open source without all this kind of structuring, you then are building in a silo by yourself, alone, kind of at the whim of how fast your engineering team can keep up with things. So rather, you need to have some sort of distribution, network and layer where you can build with, with a community of developers. And then another big piece too. There's if you take these large language models, you put your own data in here, you manage your compute how you would like to. You essentially have this ecosystem of AI inference that is available for applications and AI agents, but there's no way to really trust that these agents are doing the right thing or providing the right outputs. And so you need Web3 to do a lot of this trust network or layer. And again, there's kind of no autonomous orchestration. A lot of the problems that Robert was even talking about earlier. And this is kind of an interesting observation, but in our world, and I'll go into what Gaia does in just a second, but in our world, we work a lot with open source large language models. And if you go to Hugging Face, which I'm sure everyone knows, but Hugging Face is like the GitHub of hosting LLMs right now for open source. And there was like 600,000 models last August, and now there's about 1.6 million. So it's scaling at a crazy rate. And what's even more surprising is that a lot of the Silicon Valley, startups were investing billions of dollars. Like OpenAI raised 150 billion, to build their own closed source model, and then DeepSeek came out and said they trained their own model with similar benchmarks for $5 million. And so what we're seeing is the cost of LLMs is halving every 4 months, and that's probably going to speed up. And so if developing LLMs is a zero-sum game, a race to the bottom, what is the moat that we can build in? And how do us as consumers and users and developers, how do we find any value in this ecosystem? And so Gaia, we turn decentralized AI into living knowledge. And so what we do is we take any open source large language model you can find in Hugging Face. We help you take your own data, your own likeness, your own code or natural language. You can vectorize it, host the embeddings, and serve it as an API endpoint to agents or apps. And so it's you eventually will have this internet of knowledge where you can find specific trained context with a specific LLM with a specific kind of compute functionality or serving. And so we think that'll be a much more efficient internet of knowledge. And so just to kind of break down, what is like kind of the application, the GPT, and the kind of AI architecture that you're using as a consumer on a daily basis. It's much more than just this magic machine and this magic LLM that takes in some prompt and then does something. We have kind of the inference side of things where it's a lot to do with kind of very very close with data in the model. Then you have a lot of the machine learning R&D that's happening with open source models and closed source models, and then even pre large language models like this has been around for a long time. I remember I was doing hackathons for like IBM Watson like in 2015, and they were doing ML for years and never really getting traction. So this is all pretty new category, but it's going to be a near future where LLMs will look differently. Perhaps they're owned by agents themselves, or perhaps they're just a much more lightweight model that can compose itself, to be honest. Then we have compute. There's the UX UI, so how you're like serving your application, and then you have your hosting. Like, how is this agent running? Is the inference running in a cloud? Is the agent running on your machine? Like, how are you doing this? So just kind of give you guys some breakdown of that it's not just a simple front end application. And then why blockchain? Like, why AI and Web3 and blockchain? There's a lot of really cool validation and verification we can do on the inference layer, and that's where we're focused on. And so if you're creating trillions of models that are trained on a specific set of data, how do you verify that they're producing the right outputs, or perhaps they're saying who they are is trusted? You need a blockchain. You need to take the trust that a blockchain provides and use something like EigenLayer to validate your inference. We also have the compute. So a lot of folks are doing like orchestrated training with AI and using blockchain primitives like tokens to coordinate a lot of those resources. There's also data, the models themselves. All that is orchestration. We're coordinating between these resources on internet technology, and we really require something like smart contracts and tokens to have smart contract agreements and micropayments for these services. So that's like the biggest kind of piece we're seeing. And then I think there's a lot of folks focused on the security and trust of that actual knowledge base, and then even like the interoperability of these systems across different ecosystems on blockchains, and also how do we govern these components in a blockchain setting. And so basically what we're doing at Gaia, as I mentioned, we have high performance runtime. We have fine-tuned LLMs. Any LLM you find in open source and Hugging Face, we have integrated. So you can go take your own DeepSeek LLM, train it to be a Gaia node, and vectorize your data and serve it to AI agents or to apps. We have a VectorDB and prompt manager. We have all the open source tooling from the LangChain ecosystem that you can compose in your Gaia node. And then we have an open API server and a plugin system, so you can integrate various Gaia nodes or agents with other agents. I will just skip this one. I'm going to talk about the architecture a little bit. So this is kind of what I just described, but this in itself is a Gaia node. And so nodes in our world are both a hybrid instance of AI inference, but they're also a blockchain node. And so we have here the LLM, and then you have, you can take any LLM that's on Hugging Face, you can take your own data, you vectorize it. We have various tools in here you can use to basically scramble your data from natural language or code to a bunch of ones and zeros that are embeddings, and then we host those embeddings in a VectorDB called Qdrant, which is open source. And then you can use various open source tools in this setup. And then you also have this API server. So now everything that's in the box can be served as an API. And anytime you call to the API, you can get routed AI outputs. And so what's really cool is like you can actually take something like let's say like the Korean language of like a chemistry book in Korean language, and then you ask the book a very specific question in Korean about perhaps mercury. What's the temperature of mercury? It's going to give you the right response, versus if you asked maybe ChatGPT, it might give you the temperature of Mercury, the planet, and also maybe hallucinate on a bunch of other things because it doesn't know Korean that well. So there's really cool like context-specific things you can do here. The other really cool thing about our architecture is it's all running on an application runtime called Wasm Edge that we maintain with the Linux Foundation. And it basically enables this whole component to run on any, it can run on your machine, it can run local, it can run on a GPU, CPU, cloud, We run some on like AWS EC2 instances. It's not super compute heavy because it is a smaller large language model trained on a specific context. And so it's not your one-stop shop for everything you want to do on one node, but you can start to have collective intelligence where you have various nodes trained on specific context. And then what we're getting to in our world is having a lot of integrations available, both in open source AI and in Web3, so that your inference agent can have more ability to, perhaps have further governance, resource coordination, like financial infrastructure or process automation, and even like identity and reputation. We the node ID up there. So each of these nodes has a blockchain address, and then the Gaia domain, which I'll go into the network architecture in a second. We built those on ENS, for example. So you now can have, like right now I have like a mattwright.eth. You can also have mattwright.gaia, and that's your short name to your knowledge exchange. And so we see this internet where we'll have domains where people can go and call the right knowledge for applications. Briefly, I'm going to go into our network lightly. This is the first time I'm pitching this in front of people. So here we go. Do it live. So we have domains in our world, and we have domain clients. So right now, if you look at a lot of these AI agents, under the hood, they all are using OpenAI APIs as their endpoints. So it's like a little front-end app, and then it calls OpenAI, has it do some Web3 kind of shenanigans, and then somehow is trained to deploy a smart contract and tokens. There's a lot of human in the loop in the current agent world, and in Gaia worlds, we've made those API endpoints compatible with any kind of JSON OpenAI standard. So agents can now swap out their OpenAI API for a context-specific Gaia API. And so those are the kind of domains and clients. The nodes that I showed you earlier, so we have like 3 types of nodes in our world. We have the domain node, we have verifier nodes, and miner nodes. They all are essentially the same architecture. The only key difference is that domain nodes set the rules, so they can essentially say which nodes can provide the outputs to the domain. So if you imagine you're like an agent app, it's like my virtual twin is like doing some sort of tasks on the internet. That would be the client, and it's asking for, hey, translate my article to Korean language, and my node or my request needs to go route to a Korean domain. Perhaps it's crypto Seoul domain, and then it needs to go source, okay, which node can actually provide me the right output. And so there's a lot of coordination here where you need to have the right sourcing of which nodes will provide the right outputs that are requested. And then you also have this miner node, which is focused on coordinating compute. So that's a whole other added problem to the mix. And if you look at it from the other perspective, from bottom up perhaps, say you are this domain expert on Korean language, and you say, I want to put my knowledge, my specific knowledge, into a node and have it, fulfill these services. So you would be, providing that knowledge to the ecosystem, and then you perhaps are like a professor. You don't want to be running nodes. You're not an engineer. You would go and request that someone handles your compute load. And so we have these different kinds of nodes for coordinating that resource. And at the end of the day, like domains will be where companies end up moving a lot of their knowledge to, and serve that to their own ecosystems as applications. So just a little bit more higher level orchestration, but I'll skip that one. Yeah, and then so kind of where we're working with EigenLayer 2. So we have the miner nodes, which are coordinating a lot of the compute resources. We're building an EigenLayer AVS for the verifying of this inference. And so if you think about it, if we have an internet of trillions of these nodes, one's trained specifically on, again, like maybe, chemistry in Korean, and one's trained on like, how to make sushi in Japanese, and for whatever reason you need to, combine those two for an output, you would need to verify that this node is the right one to perform that task. It's kind of like YouTube. You go to YouTube, you look for a video on how to dance salsa, and you see like a million videos on how to dance salsa, but you see like a few of them that are, with a blue check mark and have a lot of comments, a lot of likes. That's probably the one that you're gonna go watch and fulfill your request. And so we're using the trust from the blockchain and from Ethereum to verify that these nodes are able to perform the task and that they are correctly performing the task. And then again, like the domains are just kind of the quick way to go and access that service. And it's also a way for us to coordinate a lot of tool providers. So on the domain level, say you're Uniswap and you're sitting on a ton of data and you want to become an AI company, essentially. Are you going to use OpenAI? Likely not. You're going to be giving them all of your proprietary data. They're going to be making money off of you, and then they're going to go and charge you to use it again. So you end up using your own data and paying for it. Whereas at open source, you can go and take an open source LLM. You can train thousands of nodes on specific context. Say one node is trained on Uniswap developer docs, one is trained on LP pools from some category or years, and then perhaps you have one node that's trained on specific tooling architecture. You basically can enable Uniswap to now become this AI server where if you're an agent in the Uniswap ecosystem, you can use the uniswap.gaia API as your LLM instead of going and using OpenAI. It's great for the community because you can also program in really cool Web3 primitives, like say Uniswap gives this as a free service to the community. If you have a Uniswap V3 like LP NFT, or perhaps like you are a user of Unichain and now you can be permissioned to access this Uniswap AI app. And so there's all kinds of cool things you can do and program with Web3 and AI. But we're really enabling developers and companies to become their own AI companies. I won't even go into this details, but yeah, this is just kind of like how some of the requests are processed on our nodes. Just kind of explains how how basically like the coordination process of if you are a client requesting some sort of output, how is this kind of being distributed to a committee of the domains. I'll just skip across. But the way we look at the world is, we believe that there are going to be more AI agents on the internet than humans on Earth in the next 2 years, maybe less, the ways things are going. And so, there's a lot of demand on the agent side. People are building agents that can, have their own wallets. They can vote on things. They can govern on blockchains by, permissioning or delegating voting rights. There's also agents that are, gaining autonomy. They're now, gaining reputation for doing tasks, and that is permissioning them to then go do another task. We ran an AI agent ran hackathon in October. The whole hackathon end to end was ran by AI agents. It wasn't perfect, but we had agents posting bounties. We had agents judging the hackathon, and then we had an agent distributing the bounties. And end to end, we had some human in the loop, but we distributed $50,000 in 6 minutes to all the Wright hackathon participants. And I see a future where a lot of these coordination efforts we're doing on the internet will be automated and done by agents. And they're slowly starting to have their own context, have their own ability to think. And so we see agents everywhere. We see agents with jobs. I think it's cute that these agents have meme coins, but we're more interested in agents with jobs. And if we are instigating for this new internet species that can now have its own identity, reputation, do tasks autonomously on the internet, what does that mean for us as the knowledge providers and as the humans who have kind of had this expertise over whole careers and lives? And so we need to onboard the world's knowledge into this domain so that agents can demand that as a service. They're not going to have full context to execute some tasks. They're going to need humans to kind of guide them. So it's very important that we build kind of this supply for them. And so we see a lot of this proprietary knowledge as like commercial solutions. We see the world of enterprise and creators trying to onboard their IP into this ecosystem. We're talking to a lot of creator projects like TikTok Shop and Mattel, for example, who see agents being a really cool new customer segment, and they want to essentially be providing their knowledge and make sure that they're monetizing it before they become monetized. And so we see a lot of IP owners onboarding. We have a lot of agents that now can coordinate with each other on different deployments, so they can share resources with themselves. We also see a lot of data and model and compute orchestration. So there's a lot of multi-agent systems that are kind of coming out, swarms. We see in our world, like with inference, it's more efficient when you have one agent doing one specific task, and so it makes a ton of sense for us to have thousands of agents that are trained on doing those specific outputs. And so we also are building an MCP registry with a group called Mother, and that's like the big problem with the multi-agent systems is that if you have all these agents doing their own specific tasks, how do you enable them to coordinate amongst each other? And perhaps how do you get agent 1 to source a job for agent 2? How do you get agent 2 to receive commission for doing that task and sourcing that task? And so we see like a huge future where there's a lot of demand in this ecosystem, and they're all going to need applications. They're all going to need wallets. It's more likely that an agent's going to go, open up a MetaMask wallet rather than going to open up a Wells Fargo bank account. It's just much more permissionless. And so if we see this demand growing, we believe that we could be, if this demand are like vehicles on the road, we see ourselves as kind of the supply side. We want to be the gas station or the electric company, providing a lot of the inference for specific AI outputs. But there's a ton of stuff you can build. We have some cool videos on Twitter and on our GitHub. We have an awesome GitHub if you're a dev. So there's a bunch of these quick starts on how to deploy your own node. Again, you can run it on your own computer. You don't need a blockchain. You only need a blockchain once our network's live and you want to serve it and monetize your own data. But you can also go to YouTube. I think we have these on YouTube. We did an integration with MetaMask Delegation Toolkit. So now your agent inference or your inference agent can now permissionlessly sign smart contracts. You basically give it permission to do so. And then we did an integration with Coinbase's Agent Kit. That Agent Kit is what we use to distribute the $50,000 for the hackathon. But instead of using OpenAI, you can just use Agent Kit and Gaia. If you wanted to like run your own secure Coinbase agent. And that's pretty much it. I have these are developer docs in Korean, if that's easier for anybody. I don't speak Korean, but I thought it'd be cute. And then there's our GitHub. Feel free to get in touch with me too. I have on the next slide, I have my email. But appreciate everyone listening. Thank you for having me. Thank you.